Hello, Simon. Welcome. Please come in to welcome at the Rosendahl Nextrom to our headquarters here in Austria, in Bischelsdorf. A little bit about our background. So we are member of the Knill Group. These are our owners. It's a family-owned business, and here you see our owners, Christian and George Knill. Mm-hmm. The legal name, when you talk about Rosendahl Nextrom, it's always Rosendahl Nextrom. And here we are serving 3 different industries. You see here at the back side that the brand Rosendahl is our entity serving the cable and wire industry. The brand Nextrom, our entity from Finland, close to Helsinki in Vantaa, is serving the fiber optics industry with equipment. And today you are a guest at BM. BM stands for battery machines, where we are serving the worldwide industry for lead acid battery production and as well lithium-ion batteries production. So now we are going to our factory, to our workshop. I will first show you an overview of our workshop that you see here. So you came in at our main entrance, our oldest buildings out of the 70s, and the factory was later on extended in multiple steps. And we will enter now the workshop, which is about 23,000 square meters. And what is particular to it, we have about 30% of our space reserved for process development, where our engineers have our machines installed without real direct customer background, but available for testing and development of processes with customer and market material. Here, the first blue part is the area reserved for our cable and wire colleagues. Then here the second blue area is the area where our lead acid battery systems are developed and improved. And at the end of our tour, we will stop in our lithium-ion development center, where we have real machines to show to you and where we can do processes up to prototype development. So you see here our, let's say, classical production, milling, grinding, polishing, some hardening, what we can do ourselves here. Compared to international industries, it's a relatively small workshop. We focus here on the important parts which are necessary for our own machines and processes, so not in mass production for the general industry. Okay. And of course, our machines are designed in a way that we try to use also standard parts from the industry. Yeah. For example, back in the 60s or 70s, we even produced our own gearboxes for our machines, but this is a long time ago and not necessary nowadays. So these kind of machine parts we take from the standard industry. Okay. Always from Europe. So all our equipment that we use in our machines, all the single parts, are sourced from European standard and quality suppliers. So you see a little bit the raw materials where we start. So we buy them in already pre-cutted way in the correct grade that we need at the end, and then we start our production processes. And of course, we do the drawings ourselves, so the machine construction from mechanical parts, but also from electrical circuits are done in-house as well.
So you're vertically quite deeply integrated,
yes,
correct?
So we say that even that we source a lot of parts from outside, like motors and controls, we are highly integrated machine manufacturer, starting at the single metal pieces or other material components up to the final machine, including, I will talk about it later on again, the PLC system coming from our internal sources and the process as well. You see here all the different stations that we need for the single part of production. We try to do most of the steps ourselves, especially for critical, process critical parts, like the last tooling in a process. Yeah. this is what combines all our different businesses.
Yeah, and you have a quite dense supplier network around here as well, right? With
Yes, of
Magna
course.
really
So
close by.
we are very close to Graz. There is a good supplier network, not only to automotive, but also to heavy industry like in Weiz company, Andritz, Siemens Energy. They are located not far away. So we are really surrounded by traditional industry. So an important part of every production unit is the testing laboratory. We will now visit our test center where we check every part that is produced in-house, but also our incoming equipment, of course. And we can go down here to 1 mil of a millimeter in testing precision. So, as you took just a close-up in our production from polishing of a distributor from a cable extrusion line, here you see a similar part where it's just measured automatically in terms of production tolerances. So here I gave you a very brief overview of our single production workshop. And now we will come to the next part of our factory. Here we're seeing an interesting machine, one of our main machines from our lead acid business, an enveloping station for lead acid battery cells, where single lead acid plates are pushed in automatically and then enveloped with the separators. Highest cycle speed is about 0.2 seconds per plate. One of our traditional machines is the enveloping machine for lead acid plates. Lead acid is our historic background when it comes to batteries. We have more than 50 years of history in machine building for the automatic assembly of lead acid batteries. And that was also the way how we came into the new energies business with lithium-ion batteries or similar technologies. This machine is a perfect example for our multidisciplinary performance at BM Rosendahl. So this machine combines mechanics, electronics, control system, up to process development. So we are getting here materials from the customer and from specific suppliers, and we are here testing and improving the process until a high performance, high quality product is coming out in high output.
Okay.
We have made a separate building for all our lithium ion related projects in terms of safety, so that we have a really physical separation from our other businesses. Also, our offices are here in this building to have really development, sales, project development all together in one small area.
Yeah.
Simon, welcome to our Lithium Ion Development Center. So what you see here next to some exhibition samples, mainly we focus on the processes like laser welding, what we see as one of the top processes in module and back assembly, mainly in module assembly for the bus bar connection onto the cell terminals, but also on other processes like automatic cell testing and stacking, and a new process that I will show you, automatic strapping or bending with metal tapes for prismatic cell stacks, mainly used in the BESS stationary battery market.
Okay.
You see some sales samples of the products that we have done on our equipment. So a module showing the strapping of single cells stack with its end plates and steel metal straps, and on top of this stack then it's a final module when you add the bus bars. So we did the automatic cell testing, cell stacking, strapping of the stack and welding of the bus bars so that you have a final module which is later on combined to a pack. Here a little bit more what else you can do in addition to welding of bus bars, where laser welding is clearly the best technology. You can also use this technology for welding of housing elements, in this case a steel housing of galvanized rolled steel. Nowadays a lot of people are talking about 46 type cylindric cells. We have also done here the connections of the plus pole, especially here the minus pole connecting an aluminium bus bar to a steel can. Together with a partner from Graz, company Kite-Rise, we have already done modules with sodium ion prismatic cells. Here in the background you see our laser welding station number 1, which is equipped with 2 different lasers. The first one is an IPG 1.5 single mode fiber laser, and as a second option we have here on the same station also a 6 kilowatt multimode fiber laser. So my colleagues are right now doing a development of parameters with raw materials, so single sheet material, where they are testing and improving the laser welding process. You see here inside such a test station, we are doing a lot of tests with different equipment from the market. A big topic in laser welding is inline monitoring. So with this real machine and our experts, we have the capabilities to test the latest developments in inline monitoring with a real laser welding equipment. And we are doing regularly tests here with the different suppliers from the laser welding industry. We also have here the capabilities to test different materials from the customers with different scanners if needed, different laser sources. Because it fits the sequence, we will go now to our second laser welding station over there. This is a 8 kilowatt multimode laser, disc laser, especially installed already in a fully automatic cabin designed for the production of big prismatic modules, mainly used in stationary applications like it's nowadays used in the market of BESS for container-sized stationary lithium-ion batteries. You see here a mock-up module with the standard cells now in stationary battery business, 314 ampere hours prismatic cells stacked together with metallic strapping and the bus bar connecting unit on top, ready to be welded on our laser welding station. This laser welding station is a perfect example of our complete process supply to our customer. So we can do here the process development. We can train here the customer. Very often they are new to laser welding. We take care about the automation and the correct equipment, and on top of that also include the safety measures which are necessary for the production of lithium-ion batteries. In addition to the equipment that you saw and our experts, you need a laboratory to analyze what you do, because you cannot always look inside what happens in laser welding. So you see here the important part, our laboratory, where we can do tensile strength test to test how strong is the connection mechanically. Then we can do precise cutting and polishing to go later on to microscopic and macroscopic analysis of the welding seam. One of our latest developments, you see here a prototype machine, the first prototype for this kind of process, an automatic strapping machine to apply metal straps to a prismatic cell stack. We see this application of strapping or banding especially in stationary batteries, BESS, but also in off-road battery applications. This machine can apply an open metal strap to compensate tolerances of the stack and compress the stack, measure the compression, keep the compression in the correct range, and close the strap by resistance welding so that you have a repeatable and measurable industrial process of strapping or banding. All single processes in a production need to have their own control unit, also coming out of our hand. A connected production also needs a control system on top of it to collect all the data and help the operator to improve it, to analyze it, to find mistakes immediately. After 27, we will be obliged to provide a battery passport. So you need a report where all the data of your production is supplied with the battery system. So the message in short, together with the production equipment and the processes, you're also getting the control system, BMCC, to collect your data and do the necessary analysis and reporting. So here you see our robot station to test with our customers the cell testing, cell gluing, cell sorting until the cell stacking of their product. We have the capabilities to run all type of cells, prismatic cells, cylindric cells and pouch cells, and we can do here different test assemblies depending on the customer requirements. Of course, we are working closely with our educational partners, and here you see one example of it, the Technical University of Graz, taking also part in the students' formula competition, and we have supported them with our welding competence for their high-performance lithium-ion battery.